Hi friends, welcome back on our YouTube channel. Here we are available with another lecture of classical mechanics in which today we will discuss about Hamilton equation of motion. In the current lecture, we will discuss about Hamilton's function, that is Hamiltonian, which is represented by h, and also about the Hamilton's equation of motion. So first of all, Hamilton function, that is Hamiltonian, which is represented by h. So Hamilton's function or Hamiltonian, let the Lagrangian of the system be L, and L is the function of q1, q2, q3, qn, q1 dot, q2 dot, q3 dot, qn dot t. It means L is a function of q dot and t. Q is coordinate, q dot means velocity, and t for time. So Lagrangian is the function of coordinate, velocity and time, and Hamiltonian h is equal to sigma I pi qi dot minus L. Since canonical momenta pi is equal to del L upon del qi dot, so if we replace this pi with del L upon del qi dot, then Hamiltonian h is equal to sigma I del L upon del qi dot into qi dot minus L. Here h is a function of q, p and t. It means h is a function of coordinate, momentum and time, and this h is the Hamiltonian of the system. So L is Lagrangian and h is Hamiltonian. Lagrangian is a function of coordinate, velocity and time, whereas Hamiltonian is a function of coordinate, momentum and time. Now, Hamilton equation of motion. Let the Hamiltonian and Lagrangian of the system are h is a function of q, p and t, and Lagrangian L is a function of q dot and t. So we have already mentioned here that Hamiltonian is a function of coordinate, momentum and time, whereas Lagrangian is a function of coordinate, velocity and time. And also h is equal to sigma I pi qi dot minus L. This L is Lagrangian and h is Hamiltonian. Now if we find the total differential of h, then dh is equal to del h upon del qi into qi dot plus del h upon del pi into pi dot plus del h upon del t. Because h is a function of q, p and t, so its total differential is given by this one. Now h is equal to sigma I pi qi dot minus L, and if we find the total differential of h from here, then dh is equal to, first of all, pi constant, and differential of qi dot is qi double dot, plus second time qi dot is constant and the differential of pi is pi dot. Now L is a function of qi dot and t, so its differential will be minus del L upon del qi into qi dot minus del L upon del qi dot into qi double dot minus del L upon del t. So dh is equal to pi dot qi dot plus pi qi dot minus del L upon del qi into qi dot minus del L upon del qi dot into qi double dot minus del L upon del t. Now canonical momenta pi equal to del L upon del qi dot. So we can replace this del L upon del qi dot by pi. So dh equals to pi dot qi dot plus pi qi double dot minus del L upon del qi into qi dot minus pi qi double dot minus del L upon del t. Now this pi qi double dot and this pi qi double dot will be cancelled out. So dh equals to pi dot qi dot minus del L upon del qi into qi dot minus del L upon del t. Now we can rearrange this equation So dH equals to minus del L upon del Qi into Qi dot plus Qi dot Pi dot minus del L upon del T. Since this is dH and this is also dH, by comparing these two equations, so if we compare these two equations, then del H upon del Qi equals to minus del L upon del Qi, del H upon del Pi is equal to Qi dot, and del H upon del T equals to minus del L upon del T. So if we compare these two equations, then we get this equation. Since Euler-Lagrange's equation of motion for holonomic system is d by dt of del L upon del Qi dot minus del L upon del Qi equals to 0, and canonical momenta del L upon del Qi dot equals to Pi. So this can be replaced with Pi. So d by dt of Pi, that is Pi dot minus del L upon del Qi equals to 0, or Pi dot equals to del L upon del Qi. Since del L upon del Qi equals to minus del H upon del Qi, so Pi dot equals to minus del H upon del Qi. So if we compare these two equations, then we get Pi dot equals to minus del H upon del Qi. Also from here, Qi dot equals to del H upon del Pi, and these two equations are known as Hamilton's equation of motion. Here we end our session. In today's session we have discussed about Hamilton's equation of motion. Goodbye.